Hi, I'm Fernanda.
Hello, I'm Kay.
For this week's reading response on heavy timber and CLT, we'll be going over key concepts and then some exit interview questions and finishing it with an example. So looking at heavy timber construction, it is a post and beam structural system made with large dimension wood members, which includes glulam as well as other engineered woods. And it also has solid sawwood members. And this construction is typically done with cross-laminated timber as well as large format load-bearing wood panels. For floors and roof, they're typically done with decking of heavy planks covered with a layer of finished flooring. You can see on the left here examples of ways that these decks are put together. And the connection between the members is usually done with iron and steel components. When it comes to beams, there needs to be a gap to protect them from moisture from surrounding materials. For the walls, at least 2 layers of board at 1-inch thickness, and then for cross-laminated or laminated timber panels at least 4 inches thick or 1 hour fire-resistant construction. Another, well, considered for some as a con are the exposed systems necessary with this type of construction. Now thinking about code, this is considered type 4. The wooden members are standardized, they have nominal names, nominal sizes, and then the exterior walls must be constructed of non-combustible or fire-resistant materials, and soon they will be considered a separate type of construction. Thinking about sustainability, it has a lower embodied energy and it has a favorable carbon footprint, and this is compared to steel, concrete, or masonry structures. When it comes to fire resistant, these larger members of wood are slower to catch fire and also slower to burn. There are 2 major protection styles. The first one is the char, in which it burns on the exterior while allowing an inner portion to still be load bearing. And then there's also encapsulation, in which they are covered with gypsum boards to protect them. When thinking about these connections, they're commonly done with steel, and they're fastened in ways that account for the wood shrinkage, especially in beam and grinder connections, as you can see above. And these fasteners serve to hold the members in position, but they are likely not load-bearing, though they can be.
I'll be going over some details about CLT, which also stands for cross-laminated timber. So they're often associated with structures exceeding the building code height limits of conventional heavy timber frame construction. And each layer of wood is oriented by members alternating in terms of their grain between layers, which make them a lot more strong and a type of engineered wood lumber. And then for North American CLT, they usually go by 3, 5, 7, or 9 layers of panels. So yeah, they usually use 2x6 finger jointed lam stock or glulam. Our first question about CLT is, how does the exterior wall assembly of CLT differ from the interior wall assembly? Well, one thing to note is that the exterior wall has a lot more material within it than the interior wall, is because it's exposed by the environment. So it requires like exterior cladding, the airspace, and thermally broken anchors, while the interior wall is less thick and it uses just like some of the same materials like gypsum wallboard and 2 layers of type X gypsum wallboard. Second question, what does the floor to ceiling assembly look like for CLT? So going from the top, we have finished flooring, and then 1-inch non-combustible covering, 5-layer CLT, so that's really thick, and then 2 layers, 5/8 of an inch type X gypsum wallboard, duct work, and other surfaces that can hold aircon or heaters, and then finally the suspended ceiling and below. And then our last question for CLT is that, since CLT panels do not work well when being stressed beyond their capacity, what should be done to provide more lateral force resistance? So there are 2 approaches you can do. One of them is that you can provide more panel strength by over-designing the CLT to compensate for the brittle behavior or the ductility. And then another one is that you can include ductility through the connections between the panels. But a con to that is that the panels will remain square and rock slightly as the connectors flex, which is a behavior called rocking walls. Lastly, this is our architectural example. This is the CLT Park Harumi designed by Kengo Kuma and Associates. This is actually a temporary pavilion for events and performances in Tokyo. And the semi-outdoor space was built using a steel frame infilled with panels made of cross-laminated timber. And the result is a structure that appears to spiral upwards toward the sky.
Thank you.
That's it, thank you.